Hello YouTube, it is QNix. Thank you so much for your patience. I realize there's a bit of irony in the fact that I made that post when I got 30,000 subscribers. I said thank you so much, I'm going to try to stay as active as possible until I figure out how to celebrate. And it turns out that as active as possible wasn't very much. But I think you guys realize at this point in my life I'm very busy. I've got a lot of work things going on outside of YouTube land. I've got a lot of fun things going on outside of YouTube land as well. So I really appreciate your understanding with this. I am going to be showing you two tutorials today because these are for pretty related effects. One of them is the Chromatose effect. This was named by Jonty Master, and this involves combining the real and the imaginary, swapping the real and the imaginary components of the Fourier transform. And this ends up mostly making images and videos look darker and with these smeared colors. And I will also be showing you the Terrephying effect, which involves combining the real and the phase information of the Fourier transform, which basically involves sort of intermingling two different representations of the Fourier transform into a single image. So, in order to get started with this effect, we're going to need a few things. We're going to need a command line, we're going to need FFmpeg, we're going to need ImageMagick, and I'll go through the audio effect too, which can be done, it can be done with just FFmpeg for the Chromatose. For Terrephying, it's a little bit more complicated, but this is primarily a video effect anyway, so I'm not too concerned about the audio effect. I'm going to be doing this on Linux. I'm going to be using NixOS 24.11, but you guys can use any operating system you want as long as you can get recent versions of FFmpeg, ImageMagick, and Audacity. So let's get us started in a terminal. I have only one thing in this folder, and that is the video that I'm going to be editing currently. So let's just see what this looks like before I dive into anything. It's the Colex Entertainment logo. Cool. So I have gone through the process of upscaling a video before, but I'll quickly review that. The first thing you want to do is you want to crop and stretch the video to however you want it to look in the final product. So I worked on this before. I'll just show you an example. I'm going to take the original video and I'll say VF. The video effect is crop equals W equals 0.9 times IW. This means that we are cropping the output width to be 0.9 times the input width. I don't want a semicolon there, I want a colon. H equals 0.675 times IH. And this just means that we are cropping the output height to be 0.675 times the input height. It's going to center it automatically. So I'll just say that this is cropped.mp4, and let's play it. So that looks like reasonably good cropping. I want to use that for the final video. Now, the second step is we are going to upscale the video and we're going to convert it to individual frames. So we're going to go back to the command line where we cropped the video. But we're going to add more to the video filter. Now, what I'm doing here is probably overkill. You don't necessarily have to upscale the frame rate or the resolution if you don't want to, but in my opinion, it tends to make videos look better, so I'll be showing you how I usually do that. I have my original video. I'm going to crop it the way I normally do. Then I'm going to add a new effect. Scale equals W equals 1280. H equals 720. Force original aspect ratio equals disable. So what we're doing here is we're just scaling the video up to 720p. I think before I do that, oh, come back, there we go. Before I do the scaling, I'm going to convert the format to RGB 24. But you can do that out of order. You can go back in the command line and put that in. So we're going to convert the format to RGB 24 because in the end we're going to be using an RGB based format. I'm scaling the video up to prepare it for the next stage, which is interpolate. And this is the thing that upscales the frame rate. So the parameters here are going to be, what I usually do anyway, is the frame rate is 60, the motion interpolation mode equals motion compensated interpolation, the motion compensation mode equals adaptive, whatever O stands for, block motion compensation, the motion estimation mode equals bidirectional, and variable size block motion compensation equals 1. These are the settings I usually apply that work well for me. This is going to upscale the frame rate of the video to 60. We're going to scale it up again. We're going to have it have a height of 3840. Well, let me be a little bit more specific about the resolution here. So usually I render my videos at 3840 by 2160. This is 2160p 4K. If you're rendering this at a lower resolution, I know sometimes people do 1080p or 720p, what have you. You can play around with this. But the thing that's important is you don't want to scale this up to the size of your output video. You want to scale it up to a square, where the dimension of the square is the same as the largest dimension of your output video. So if I am scaling this up to a final video resolution of 3840 by 2160, in this step I want my image to have a resolution of 3840 by 3840. And I will, of course, force original aspect ratio equals disable. And I'll apply some denoising. Usually for upscaling, I do HQDN3D equals lumaspatial is 10. So let's break down what I am doing in this whole filter graph. I'm cropping the video so that it fills a wide screen, as I usually do. I convert the format to RGB24 because our final output is going to be RGB24. I'm scaling this up to a reasonable resolution before I do motion interpolation. The reason why I have two different scale steps here is because if I did the scaling first, then the motion interpolation at this really high resolution, it would be super duper slow. But if I didn't scale up this to this resolution, then the motion interpolation would be poor quality. So usually what I do is I scale it up to a resolution of 1280 by 720, then I do the motion interpolation, then I scale it to whatever I actually want. I scale it up again, and then the final step is the denoiser. Now we're going to add a few more parameters to get our final images. We're going to say that the pixel format is RGB 48. I forget if it's BE or LE, but it will correct it if I get it wrong. I think it's BE. And the aspect is going to be 1:1. It's a square. and I'm going to call this frame 03d.png. Now, here's the final step of this whole command line. The pixel format says what depth of information are we going to use to represent the colors in the frame. And we want it to be very large because the Fourier transform is extremely sensitive to colors. So we want to have the depth be as high as possible. We don't need an alpha channel and we don't want an alpha channel. So this is definitely the color format that you want going into this step. The aspect 1:1 just means we want to make sure our output frame is a square. And then finally, naming this frame with some sequence.png means that instead of outputting a video, we're going to be outputting a series of images. Now, I know that the input video I have is very short, so it's only going to be like 200 something frames after I do this upscaling process. If you have a longer video, you can increase this number here to 4D or 5D or 9D, whatever. So this should be everything. Let's run this. Okay, so I was correct about the pixel format. Oh, and finally, I suggest using PNG because PNG is a lossless format. I tried using JPEG 2000, and it's interesting with JPEG 2000 lossless. Sometimes it gets a better compression ratio, sometimes it gets a worse compression ratio, but it's always slower to use. I would like to use JPEG 2000 more because it's very flexible, but I find that for this procedure, PNG just tends to work better, so I'll go with it. We should be almost done because this logo is very short. I did that on purpose because I am going to be working with limited disk space because I'm doing this locally. Normally I would do this on my research server where I have all the disk space in the world. Okay, so let's take a look at one of our frames. Oh, that's strange. Why didn't it like that? Let me do it this way. Okay. So this is what our output frame looks like. It shows the logo stretched and cropped the way we want, but it is in a square format. And, you know, this logo hasn't finished playing because I just chose a random frame in the middle. Now, I'm going to be showing you the ImageMagick command line on a single frame so we can see what this looks like. This is the part where we actually apply the Chromatose video effect. I'm going to be starting with Chromatose, and we're going to be using ImageMagick. This is a very simple, well, I don't know about very simple, but relatively simple because this is a single step, whereas Terrephying is multiple steps. So I'm going to use frame 100 as my test frame. And let's see what we're going to do here. We're going to apply the Fourier transform, and we're going to add the plus, because with the plus, we want the real and imaginary components. If we used a dash, we would get the magnitude and phase. That wouldn't work out the way we want. Plus depth, because we want to preserve the color depth as much as possible. We are going to swap 0. After running these two things, we are going to have separate real and imaginary components. We want them swapped. I admittedly don't totally know how the numbers work with swap, but I know that swap 0 works. I think what it means is you supply a number and it swaps that channel with whichever one comes after it. We are going to apply the inverse Fourier transform with a plus. because we're still working with real and imaginary components, plus depth. At this point, the component should be swapped, but our output video isn't going to look right because it's going to be flipped over. So let's rotate 180, and I'm going to call this test.png. So let's give this a try, see what it looks like. It'll take a minute because I think when I swap the components like this, it's kind of like going out of range of the Fourier transform. See what happens. Oh, it still didn't like that. Fine, I'll just direct it to dev null if you're going to be like that. Okay, so this looks great. Well, I mean, it doesn't look great, but it looks correct. This is what we're going for. We have this mostly black video with some colors that are being smeared across the board. And interestingly enough, some areas right at the end of the stripes that actually have the color that I'm expecting. So cool output here. So that's what the command line looks like for a single frame. But we're not going to get anywhere if we do this effect on a single frame. So to make my life easier, I'm going to be using GNU Parallel to apply this to multiple different frames at a time. You don't have to use GNU Parallel if you're using an operating system that doesn't support it or you just don't want to install it, but your life will be a little bit harder. I'm going to do parallel, and let's say J. I'm not using too much CPU. I'll do load 80%, mem-free 80%. I'm going to construct the same command line that I just did up there, and these braces are going to be the name of my input frame, plus FFT, plus depth, swap 0, plus IFT, plus depth, rotate 180, and I'll call this Chromatose and I'll apply this to all of my frames. And let's do a progress indicator so I can see this. So this will take a minute. I'm probably going to let this proceed and just skip ahead, edit out the part where this is going, so that we can get on to the next part. Okay, we have applied the Chromatose effect to all of the frames in our video. So now what I'm going to do is I'm going to join them all, and I'm going to combine that with the audio effect, the corner logo, all that fun stuff. So let me just link my corner logo in here. So this is a big one. It's the last step of the chromatose. Before I type it, I'll just show you the names of the PNGs. They're all chromatose followed by frame with some 3-digit sequence number. So let's do chromatose frame o3d.png, And just to be extra safe, because FFmpeg really wants images to be 25 FPS, I'm going to put frame rate equals 60. Oh, not frame 60. Frame rate 60. We are also going to add our original, and we're going to add our corner logo. So, let's see what I have to do here. Yes. So we're first going to use lavfi instead of VF because we're working with multiple sources. 0 refers to our first input source, which is the Chromatose frames. Now, FFmpeg will automatically handle converting the image sequence to a video, so we don't need to apply any filters that explicitly say that. But we are going to apply a filter that scales it to a widescreen resolution. And there it is. I think that's it for the video. So I'll call that NL for no logo. Let's do 2V. For some reason, my logo has a silent audio track. It should just have no audio track. So I'm doing 2V to make sure that we don't get the audio in there. I'll also scale this to the right size. I won't do force original aspect ratio equals disable because my corner logo is already rendered in widescreen, so I don't need to worry about that. Call this LG for logo, and then NL LG overlay, which I refer to as FV as final video. So all I've done here is I've scaled my Chromatose frames to 2160p, I've scaled my logo to 2160p, and I've put them on top of each other. When you overlay your logo on your video, make sure the video without a logo comes first and your logo comes second. Otherwise, it'll try to put your video on top of your logo, and that's not what you want. Then I'm going to work on the audio, 1A, because we only want the audio. Let's see what I have to do here. So first I usually do a resample equals 48,000, which means I'm upsampling the audio to 48,000 hertz. Usually I do a exciter, a FFT-DN. This increases the quality of sound that is primarily low in frequency. It makes it sound a little bit more natural when I upscale the frequency. And this is just a generic denoiser. Finally, the real meat of the effect is going to be a freak shift equals 100. And I'll call this FA for final audio. I'll map FV and map FA. Now, usually in my tutorials at this point, I go through this whole list of codecs and pixel formats and parameters, flags, things like that. I'm not going to do that today because it's just going to take an unnecessarily long time. At this point, you should be putting in the parameters that would be required for a YouTube upload. So usually the codec is going to be H.264, the pixel format will be YUV240p, whatever. So I'm just going to let it choose defaults for today's tutorial, and I'll call this Chromatose.mp4. Now, when you load an image sequence into FFmpeg, it usually takes a minute to get started, and it could potentially take a long time if you have a long video. So don't worry if it freezes when you start. Usually once it finally processes the input sequence, it'll be faster. I'm going to actually reduce the resolution of this so I can play it. If I tried to play this at full 3840 by 2160, it would be upset. My computer would be very sad. Let's say the size is going to be 1280 by 720, frame rate of 30, Chromatose small. Let's play this. Okay, so we're almost there, but it seems like FFmpeg decided to make the output a square, even though I didn't want that. So let's go back up to the command line where I rendered the video. And I'm going to say that the aspect is 16 by 9. Let's see if this works better. Oh, oopsie. There we go. So let's try rendering this again. And then I'm going to resize that like I did before. And we're gonna play it. That is much better. So when you do the actual rendering of the video and you put all of these switches to control the output size, codec, flags, pixel formats, and all that, make sure that you also put dash aspect 16 by 9 so that it doesn't try to make your output a square. So that's it for Chromatose. Actually, before I move on, I do often get folks wondering how to do the render without a logo. So let me show you how I would do that. The audio effect is going to be the same. The video effect is going to be the same. What we're going to do is we're going to remove the scaling of our logo because we don't have a logo. And we're going to remove overlaying the logo onto our video because we don't have a logo. And then finally, because NL is our output, we're going to map NL. You can name this whatever you want, but just whatever the name of your output is after scaling your video is what your output should be. So I'll just quickly render this bad boy. It's taken a hot minute. Did I do something different? Let me just check to make sure I didn't do something different, because this is using... Yeah, you know what? I'll let it go. I'll let it go through and I'll figure that out later. Alright, and then I'm going to resize so I can play it. And then I'm going to play it. Yay, no logo. Okay, that's it for Chromatose. You scale and crop your video the way you want. You switch the real and imaginary components of the Fourier transform per frame. You combine all the frames and you apply frequency shifting to the audio, and there you go. Now, as usual, you guys know you don't have to combine the two effects, the video and the audio, the way that I've done here. Please feel free to mess with this and incorporate some of the things I've done into your own effects. We're moving on now to Terrephying. So I'm going to remove, just to save me some space, remove anything Chromatose. Now, Terrephying is a harder effect to do because unlike Chromatose, it is not possible to apply the effect to a frame in a single command line. You have to use multiple commands. So we still have, from our previous effect, we have all of the frames that we had before. So normally I would go through the cropping and the scaling and all that, but I've already done that for Chromatose. You're just going to do the same thing for Terrephying to get your individual frames. Now, the commands that you're going to apply to each of these frames, there's no use in me showing you what the intermediates look like because unfortunately they're in a format that we can't really view. So I'm going to run this in parallel. I'm going to do the same things I did before, limit CPU load to 80%, limit free memory to 80%, all that stuff. And I'll use a different progress indicator so I can see how intense this process is. So, in this parallel command line, the bracket represents the name of my frame. If you were running this for a single frame, you wouldn't use these braces, these curly braces. You would just use whatever the file name of your frame is. We're going to do FFT with a plus, because this is the real and imaginary components, plus depth. We're going to escape a parenthesis, and we'll clone the first channel. This is the real component. We'll write it to real, followed by our frame name. And I'm going to change the file extension to .mif. The reason why I'm changing the extension to .mif is because ImageMagick has this special file format called Magic Image File Format .mif, which is the best way to preserve information when you are working with multiple ImageMagick steps and you don't want to lose quality or things like that. So my understanding is that this is lossless, and when we're working with things like the Fourier transform, which are very sensitive to losses in quality, we're going to want to make sure we use MIF whenever we can. This, however, is going to involve a lot of disk space, so if you're going to use MIF, make sure that you have a lot of disk space available. If you need to use PNG, that's fine. PNG is also lossless, so you shouldn't have to worry about the difference between MIF and PNG, but MIF is safer. Plus delete. Null. So what I've done here is I've applied the Fourier transform in the real and imaginary space. I've preserved the color depth as much as possible. I've taken the first channel, which is the real component, and I'm writing it to a separate image file that is the same as what's going into it, but I've tacked the word real onto the front, and I've changed the extension to .mif. I am deleting the original real component because I've already written it out. I don't need it anymore. And I'm putting the output as null because once I output this MIF file, I don't need anything else. So again, this is going to take a hot minute. Okay, we're back from running the real component extraction from all of the frames. So we're going to run a similar command line. I'm going to go back here and I'm going to change something. Instead of depending on this load and mem free, I'm just going to say that J5, maybe I could push it to 6. Yeah, 6 is reasonable. To run 6 jobs at a time. Whatever you put here is going to depend on your computer. So we're going to reuse some parts of the command line that we had before, because some of the things we're doing are pretty similar. But we're going to make some changes. Instead of doing plus FFT, we're going to do dash FFT. Now, before we were extracting the real component, so we use plus FFT because that splits into real and imaginary. Dash FFT splits into magnitude and phase. So this is the part where we're extracting the phase component. We want the dash. We're going to keep depth. Now, the other thing is that the phase is the second component, not the first component, when we apply this Fourier transform. So we're going to change this from clone 0 to clone 1. And we're going to write it to phase with a MIF extension. We're going to delete it. We're going to send the output to null. So all we're going to get is the phase image.mif. And we're going to send this to phase frame.png. So let's let this go. I think running only 6 jobs at a time was a much better bet. It seems like my computer's handling it better. I am going to, again, skip ahead in the tutorial so that we can resume when this is all done. The audio got messed up at this point in the recording, so I'm dubbing over it to tell you that at this point we finished extracting the real and the phase components, and we're going to move on to combining them. So I'm just going to check my disk space here because I think I'm about to run out. That little purple line is getting pretty high. Only 72%. That's not bad, actually. Okay, so we've extracted the real component from everything. We've extracted the phase component from everything. Now we need to combine them together. So finally, we are going to run a magic command line with 2 inputs. So here, 1 in braces signifies my first input, and 2 in braces signifies my second input. If you were running this in serial, like a for loop, this could be like for A in some set, for B in some set, and this could be A, that could be B. We're going to apply the inverse Fourier transform in magnitude and phase space. So what we're doing, the meat of what we're doing in Terrephying is we're basically replacing the magnitude with the real component. So the magnitude and phase is one way to represent the Fourier transform. Mathematically, it's considered polar, which means the value is represented as a scalar value and an angle. The real and imaginary is a different way to represent it. This, we represent the value as splitting it up between 2 components. So we're intermingling these 2 representations by combining the real and the phase. You should always put the plus depth after after these. Now, I think I'm going to change this a little bit. I want real dot mif and phase. Yeah, I don't need 1 and 2 because I'm not doing 2 different inputs in parallel. Yeah, I'll do it this way. And I'm going to call this ref So what I'm doing here is for each of my frames, I'm taking the real component, I'm taking the phase component, I'm applying the inverse Fourier transform, and I'm saving this to an output starting with ref. Now, my original frames end in .png. My intermediate image files, real and phase, end in .mif. But my output here is going to end in PNG because these are the images that we're going to be putting into FFmpeg, and FFmpeg doesn't understand MIF. So we only use MIF for our intermediate steps in ImageMagick where we extract the real and the phase, but now that we're combining them, we can go back to using a PNG. So it's going to do its thing. You guys know the drill. I'm going to stop here and come back, skip ahead a little bit, and come back when it's all done. Okay, we are back from the adventures of waiting to apply the effect to all the frames. Now, something that you will realize, and something that I remembered when I was doing this, is that this step takes a really long time. But the hard part's over. Let's look at a frame. Now, I don't know about you, but I, for one, think that is a very terrifying rendition of the Colex logo. And something that you see is kind of interesting is that, yeah, of course, the video is extremely messed up, but there's tiny little features. Like, this looks like the letter C, this looks like the letter O, this looks like the letter L. There's, little signs of the original logo kind of peeking out in all this mess. Which I think makes this a really cool effect. It's almost, but not completely unrecognizable. Oh, and you also have the 3 bars here in the middle. Now, before we can combine everything into a video, we do need to apply the audio effect, and this is with, well, I shouldn't even say should. If you want to reproduce this the way I've done it, we need to apply the audio effect. I need to be clear about that. Now, this is going to require Audacity, but I'm getting ahead of myself. In order to apply the audio effect, we're going to need to extract the audio in FFmpeg and apply frequency shifting. So we're going to do something like what we did before with the video for Chromatose, the final step, but we are going to only apply the audio effect. So I'll say A resample equals 48,000, A exciter, A FTDN, and A freak shift equals 100. And I'm going to call this freakshift.flac. I think it's a good idea to render this with the FLAC codec because this is lossless. We want to keep things lossless as much as possible. And then we're going to open this in Audacity. Now, to get the audio effect here, I basically just applied even more weird filters on top of frequency shifting. So the first thing I did is I applied pulse stretch, with a stretch factor of 1 and a time resolution of 0.05. So this is kind of like pore stretch. Then I applied a vocoder with all the defaults. Then I applied the compressor with the threshold of the noise floor all the way to the bottom, and the ratio of 2.5 to 1. I applied equalization, graphic EQ, where basically every other frequency band I turned down. Then I applied the compressor again and normalized it to 0.01 dB. So let's try this. Let's see how this looks. Well, that sounds really bad, which is really good. So I'm going to export this. And I'll call it worse because it's bad, and export it. We're done in Audacity. So now I'm going to go back up to the command line that I used in order to make my Chromatose video. So this is going to be mostly similar to what we did for Chromatose. This is the final step of ref. We're combining all the frames. So let's see what I'm changing here. Our input frames are going to be ref. We're scaling that. That's all the same. Oh, and our second audio input isn't going to be original. It's going to be worse.flac. So the video effect is going to be the same. We're just scaling the frames. We are going to apply the overlay. We're going to be applying the overlay on the logo. We don't need any audio effects because we've already done the audio in Audacity. So I'm going to end my filter graph without doing any audio effects. I'm going to map FV, which is my final video, and I'm going to map 1, which is my final audio. That's just worse.flac. And I'm going to send this to the video ref.mp4. It's going to think about it. It's going to decide if it actually wants to do this. Then I'm going to resize it so we can play it. And just a quick reminder that this step I'm only doing to make it easier to play. When I upload these videos, I will have them at 4K resolution. Let's see how this looks. Ooh, that is nasty. Just the way it should be. Let's play that again. I think I saw some little hints of the subtitle. Yeah, you can kind of read it. You can kind of read it. That's cool. So, there we are. I do realize in retrospect I think I went through some steps, especially those in Audacity, a little fast. So do feel free to pause the video at any point, rewatch certain steps. Always feel free to ask me questions in the comments. Always feel free to change things up. What I've shown you here is how to reproduce what I've done. This does not mean that you are beholden to reproduce it exactly the way that I do it. You are free to change things around and have fun. And before I go, I'll just give a final warning that the effect, if you work with anything other than very short videos, is liable to take up a lot of disk space, especially Terrephying. So you want to make sure that you have a big hard disk. Also, I've talked a little bit about how I want to combine my next logo with my 30K subscriber celebration. And I have officially started work on my next logo. Let me drop a little hint for you. All right. So get thinking, get speculating. I don't have a timeline for when it's actually going to be up because I am towards the end of my PhD program, and that's really my top priority. I'm trying to finish that all up. But I am certainly going to do what I can to give you guys a really cool, awesome logo in a reasonable time frame. Thank you guys for your time today. Have fun applying Chromatose and Terrephying, and have fun messing with the Fourier transform in general. Have a good day.